Hey guys, this is a short video, an instructional video on the quotient rule. So let me start by stating the quotient rule. The derivative of the division of two functions, which we'll call f of x divided by g of x, which are our two functions, is equal to, the rule states, g of x, the original function of g of x, times the derivative of f of x, minus f of x, the original function of f of x, times the derivative of g of x. I put that to make sure derivative. All of this is divided by g of x, the original function, squared. Now in my last video I said let's ignore the denominator right now. In our last video I said it didn't matter what order you multiplied these two functions and added, because at the end of the result you're going to be adding. So the product, because of commutative property of multiplication, it didn't matter which format you wrote it or what rule you wrote it. And overall it didn't matter because the two things were going to be summed up to adding. In the quotient rule, it does matter because you're subtracting now. So if I were to switch this rule, I mean, these two can keep the same. You could play with these two because of commutative property, that still holds. But you cannot switch these two formats. This cannot be put here, and the product of these functions cannot be put there. The reason being is because you're going to be left with a negative number. Just like if I said to you, 2 minus 3 does not equal 3 minus 2, right? The same rules apply here. You cannot subtract here. So the best thing to do is just to remember this formula. To remember this as much as you can. Remember that it's the first side, it's the denominator of the two functions times the derivative of the numerator minus the numerator times the derivative of the denominator. And the reason that holds is because it matters, because this function is getting divided by this function. So this rule matters which way you do it. Okay, so that's just a precaution. So let's do an example of it, because we went over this in class, but it's always good to have more examples. So we're going to label h of x as 5x minus 2 over x squared plus 1. Okay, I'm going to find my two functions. So this will be my f of x. Call that f of x, and this will be my g of x. Okay, and just like with product rule, I like writing it to the side. I like planning it out before I even touch the formula. So my f prime of x, which is just the derivative of 5x minus 2, is just 5. And my g prime of x, which is the derivative of the g function, is just 2x. So we're not dealing with hard derivatives, so hopefully the algebra won't be too bad. Okay, so let's follow the rule. It's the original g of x, which I know is x squared plus 1, times the derivative of x, which is just 5, minus the original f of x, which is 5x minus 2. It's important to have parentheses so you don't get confused, times the derivative of g of x, which I know from here is just 2x. All of this is over gx, the original function, squared. So all of this is over x squared plus 1 squared. And I'm not a big stickler. I'm fine with keeping this at the bottom like that. I don't think I don't expect you guys. I mean, I know you guys should do it. You should be able to do it, but you don't have to factor this out. So just keep it on the bottom like that. So let's do the top. So we have to do the algebra. We distribute the 5. So we're left with 5x squared plus 5 minus okay, so now what I do is distribute first before I get to the minus sign. So I do the 2x, or you can let's distribute the negative sign first. So we're left with minus 5x, I'm sorry, let me cancel that. Okay, so we'll distribute the negative sign first. So minus 5x plus 2 times 2x. And this is getting multiplied, right? So we distribute the 2, we're left with 5x squared plus 5. Distributing the 2 leaves 2x times the negative 5x. leads me to minus 10x squared. And the 2 times the 2x times the 2 is just a positive 4x. So over, remember, it's important, x squared plus 1 squared. So let's simplify this. 5x minus a negative 10x squared. 5x squared, I mean, minus negative 10x squared is negative 5x squared. There's only one 4x. There's only one x, so we're going to do 4x. Keep that there. Okay, so we got rid of the x squareds, and we got rid of the 4x, and we're just left with a positive 5. All over x squared plus 1. Let me just extend this so we know that's all over that. And that's your answer. You don't need to do anything else. I'm okay with this. I'm totally fine with this. It would be nice to write this. I always forget it myself, but it's important to write that you're finding the derivative so you don't get lost. And this is all of the original function h of x. So our final answer comes out to the h prime of x is equal to this value. Alright, so let's just do one more example using quotient rule, and I think you guys should be done with that. Let's move over. Okay, let me get one more example for you. Okay, so we're left with, the example is going to be f of x is equal to 3 minus 2x minus x squared over x squared minus 1. Okay, so because the original function is f of x, I'm going to call my two separate functions different letters. But the same rule applies, right? If I'm saying f of x or g of x, I'm still doing the same thing. Okay, so I'm going to call this my a of x and my b of x. Okay, so I know that a prime of x in this case, so it looks kind of ugly, but it is equal to just negative 2 minus 2x. Okay, and again, if you guys have problems with finding derivatives, you need to come talk to me, because I'm assuming that we know how to do that at this point. But you know, sometimes you need a little help, and that's totally fine. Okay, so make sure this is right. So our b prime of x is just 2x, which is our bottom function, and our a prime of x is negative 2 minus 2x. Okay, so we're fine with that. Now the rule says it is the second, so b of x, x squared minus 1 times the derivative of the first, which is just, hold on one second, yeah, make sure I'm right, because I make sure the rule's right. So it's the second times the derivative of the first, which is our a prime of x, which is negative 2 minus 2x, all in parentheses, that's important, minus our first original function, which is just 3 minus 2x minus x squared, like that, times the derivative of our second, which is our b of prime of x, which is just 2x. And all of this is over the second function, the original b of x squared. So x squared minus 1. And I'm not doing some special math here. I'm just following the rule as it is. I plotted it out, what my derivatives are, and I'm just plugging in what I know into the formula. Okay, so this is f prime x. Okay, so let's do some distributing on the top. We have, let's distribute the x squared first. We have negative 2x squared minus 2x cubed. Now I'm going to distribute the negative 1 plus 2 plus 2x. Okay, I'm going to distribute the negative 1 as well, so let's distribute just this negative first. So minus 3 plus 2x plus x squared times 2x. I'm going to just separate that just so I know that I need to distribute this first, right? So all I did here was distribute this negative 1, so, and it made these all opposites of what they were. So all over x squared minus 1 squared. So now the next thing is to distribute. Let me rewrite everything. So I have 2x squared minus 2x cubed plus 2 plus 2x. I'm going to distribute this 2x to this parentheses. So we have negative 6x plus 4x squared plus 2x cubed. And again, this is all over x squared minus 1 parentheses squared, which is our second function right here. Okay, I'm going to divide these out and simplify it. Let me just do that so we know that's just, it's a divide. Okay, so let's deal with what we have first. Okay, let's look for let's look for numbers with x squared in their things. We have negative 2x squared and a positive 4. So we have a negative 2x squared plus a 4x squared. So I know that makes 2x squared. So we're left at 2x squared. Okay, x squareds are out. We're done with them. We're not using them anymore. Now we look at x cubed, which is our next one. We have negative 2x cubed. Any other x cubed right here, positive 2x cubed. A negative 2 plus 2 cancels out. We don't need to deal with x cubes at all. Okay, we have a coefficient. Let's look at 2x now. We have a 2x here, a negative 6x here. 2 minus 6 is negative 4. Keep the x's, right? So we're done with x's, and are we left with anything? Oh, yep, we're left with this 2 right here. So we just have a 2 on top, okay? This is the best way for me to do it. I mean, I see through it. I could, I see what I have to do. I cross out what I've already done, and I could keep it in a nice order, okay? Now, we still have to bring this x squared under here, right? We're not done with this. And like I said, I really don't mind. You don't have to expand the bottom, the denominator. I'm fine with this answer. So we're given that this is equal to f prime of x, which is the 2x squared minus 4x plus 2 all divided by x squared minus 1 squared. And that's quotient rule. I gave you 2 examples of it. I hope this video helps, and if you have any other questions, please come ask me in class. Alright, have a good one, guys.